Hi everyone, my name is Thomas Kim. Today is November 23rd, 2019. This is my 32nd episode about linear algebra and threading building blocks. In this episode, we will test complex number matrix using our own library. Modern C++ language is super powerful. OpenCL programming guide and OpenCL in action. These books arrived yesterday, so I will implement my matrix algorithm using Intel threading building block as soon as possible. Then we will extend our matrix algorithm to support OpenCL GPGPU programming. Also note that this episode continues from my previous episode, episode 31. If you haven't watched this episode, please watch it. Also visit www.talkplayfun.com, download, click TBB linear algebra, then double-click 31 operators for matrix.zip, show in folder, unzip it, rename, 32nd complex number matrix, copy, paste it to your working folder. This is my working folder. Start Visual Studio Code. Open the folder. Expand folder 32. Copy. Right click. Copy. Paste. Rename. Complex. Hit enter. Ctrl V. We will include complex header file for complex number. Scroll down. We will rename this function parallel matrix multiplication with operator complex matrix, like this. Copy the function name, Ctrl N, paste it here. We will delete this part, so I will remove this and I will remove all other code up to this point. So this is our new file, and we don't need this. Scroll up. Here we will define using complex T std complex double. Scroll down. This is complex T using complex element T value type. Then scroll down. This generator should be complex element T. Please note that I change it to plural form generators, and it should be clone. I create random generators. I create two random number generators. That generates instances of complex element T ranging from -5 to 5 inclusive. So 2 means we create 2 random number generators. Now here, auto complex generator return. We are returning complex number generator 0 generator 1. So this is vector, actually vector of generator, random number, okay? So it returns a complex number t. Now we paste this here, go to declaration, from this file, copy once again. This file is talkplayfun chronorandom.hpp. Copy, paste, and from here, type name, delete like this. Copy, paste, then done. Please modify your code like this. Now in complex again. Now matrix A, matrix B, matrix C are matrix of complex number. We define the matrix element T. Element T is complex number. So all these matrices are matrix of complex number. Scroll down. Stream. Determinant of A determinant Leibniz parallel and L. Copy once again. Determinant of B determinant of Laplace parallel reduce. Start command prompt. dir cd 32 complex number matrix dir. We are using Clang compiler, Clang++, std, C++17, complex.cpp, ltbb, malloc, hit enter. So we have error message, some linked error message. The problem comes from here. Right click, go to definition. We are using atomic, but this is complex number. We can't do this. So from here, if context sphere types is numerical number element type. I open block, scroll down up to this point, close. Now I will indent a little bit up to this point. Now I will copy once again. Copy, else paste. Element type is not a numeric type. Then we cannot use atomic. So we say element type. Instead, we introduce using mutex t, TBB, spin, mutex. I defined a mutex type, mutex t, mutex. I defined an instance of mutex. Now scroll down. Now we don't need this. Up to this point, mutex t, scoped, lock, mutex. Then det, partial, det. Now the remainder is the same. So we use if context pair. If the element type is numerical number, then we use atomic. Otherwise, we use mutex for synchronization. Using mutex is not a good idea, but I will do this for simple application. In future episode, we will optimize this part without using mutex. Instead, we will be using like parallel reduce algorithm or some other method. Now with this, in the command prompt again, we build again. CLS. So these are matrix of complex numbers generated with a random number generator. Matrix A, matrix B. This is complex matrix addition, A plus B. So these elements are multiplied together. This is complex matrix multiplication. Okay? Why it gives this message? Let's see. Oh, I am printing out address A times B. I fixed like this. We build again. CLS. So it works perfectly. Okay. So determinant of A is this value. Determinant of B is this value. These are complex numbers. Determinants are evaluated. We implemented this algorithm in our previous episode. So this matrix class starts from here, namespace here. The class is defined starting from this line. This matrix is actually very powerful. It supports not only just floating point numbers, it supports complex numbers. In future episode, I will add more features. Matrix element will also support lambda closure or function pointers. Then we can have our matrix element as functions. Functions can be elements of our matrix. Since I updated this chronorandom, this random field function, I will upload the C++ extension library to my website, extension talkplayfun.com website. You probably have to download my extension library again and reinstall. I recommend you watch episode 1 and install how to install C++ compiler and environment settings. If you haven't watched, please watch this video and download the extension library again and update your installation. In future, we will implement our matrix algorithm using GPGPU or OpenCL programming framework.